Hi everybody, I want to give you some examples of organic molecules from fossil fuels. So let's talk about two that you're going to be really familiar with. First, natural gas. Natural gas is 60 to 80% methane. It depends on the source where you're getting the natural gas from. The remaining 20 to 40% will be smaller amounts of like ethane, propane, and butane. Now, you've most likely heard about petroleum, right? This energy that runs the world. It can be called crude petroleum. That's what we will get out of the ground. It contains molecules that have anywhere between 1 and 40 carbons. So it's this mixture of different organic molecules, and they're going to mostly be alkanes, all right? All of these just straight chain alkanes. You'll have one compound that only has one carbon, like methane, or one compound that has 40 carbons, and everything in between. So what we have to do is distill the crude, is what it's called. You take the oil that we get from the earth, and we have to separate it into the different types of carbon strings, if you will. So this is called a refining process, and I'm sure at some point in your life you've driven by a refinery. What they're doing is separating this crude based on the number of carbons. Here's your technical definition if you want to write this down. Refining separates oil into usable fractions that differ by boiling point. And this refining process, I'm going to show it to you. It's pretty neat. Based on boiling point, we can collect different sizes of carbon molecules. Notice I put the word non-renewable. So this is our big discussion for the environment, is that organic molecules, when we combust them, they're non-renewable. Not only do they release CO2, and some people are concerned about greenhouse gases from that, but once we use that energy, it's going to be converted into water and CO2. We can't then combust those again, per se, not in an easy way, anyway at all. So once we use what we gather from Earth, the fossil fuels, and we combust them, they're gone. Now energy is transferred. We use that energy in a different way, but it's non-renewable. So we're looking at renewable sources of energy, and that would be like maybe solar power, something like that. Okay, let's take a look at, an example, here we go, of a refinery. So this is a refinery, and I'm sure that you've driven past refineries. I like this example over here. This is what you're going to see inside of a refinery stack. So you heat up this oil right here, and it is going to put the oil inside of this refinery, and then based on different temperatures, notice you have lower temperatures at the top and then hotter temperatures at the bottom. It goes from maybe 20 degrees all the way to 350 degrees. And then based on boiling point, the smaller the molecule, the lower the boiling point. So here, when we're between 20 and 200 degrees C, that's when you're going to be able to pull out, boil, evaporate the gases that are between 5 carbons and 20 carbons-ish, right in there, okay? Now, if we're between 125 degrees and 275, again, I'm giving the range, and our chemical engineers would have all of this fine-tuned. The boiling point is what we would consider our kerosene level. And these would be carbons anywhere from 12 carbons to 16 carbons. And then our fuel oil, so maybe like diesel oil would be an example of this. We're going to have the temperature be anywhere from 250 to 400 degrees C, and this will boil. It will evaporate our molecules that contain 15 to 18 hydrocarbons, or carbons, in that hydrocarbon. Another example that I thought you would find fascinating is when we talk about 1 barrel of oil, and you'll see in the news of how much 1 barrel of oil is being sold for currently in the market. 1 barrel of oil, it contains 42 gallons. Well, 19.7 of those gallons are going to go to gasoline. So almost half of the crude oil inside of 1 barrel is going to be used for gasoline. A couple of other examples for you. We're going to have diesel and home heating oil. That's going to be about 20%, 8 gallons. Jet fuel, 4.2 gallons. So about 10% of all oil goes to jet fuel. Asphalt on roads, lubricants, waxes, and then we also have to use it in chemical synthesis. So kind of an interesting breakdown of when we pull this petroleum out of the earth, the percentage of how it's used and where it goes. Nice. So good thoughts on and good education on our fossil fuels, how they're organic molecules, and how we can be responsible, how we use them, what we do industrially with those organic molecules. Pretty neat. Have a good day. Thanks for being here.